So in this video we are presented with 4 compound interest questions and the solutions. In this question we have Liam invests £6,200 for 3 years in a savings account. He gets 2.5% per annum compound interest. How much money will Liam have in his savings account at the end of 3 years? Now with compound interest you should be aware that the money is invested and no money is taken out until the end of the investment. And in this case the investment is the interest rather is 2.5% per year. So if we take the initial investment, this will always be referred to as 100%, and in this case we're adding the interest, which is 2.5%. At the end of the first year we have 102.5% of the money invested. Now to solve these questions you need to turn that percentage into a decimal multiplier. You do it by dividing the percentage by 100, and that's going to give us 1.025. That is the multiplier we use to work out how much money we have at the end of the investment. Now he invests £6,200 and we multiply it by 1.025, and we would do that 3 times because he's doing it for 3 years. So instead of writing it out 3 times, we just put it to the power of 3. And then that's when your calculator comes in. So you tap in 6,200 times 1.025 to the power of 3, and then you should get the answer of 6,676.72. Remember, with money you want to go to 2 decimal places. If we're dealing with pounds, we go to the nearest penny, so it's 2 decimal places in your answer. Now in the exam, all you would actually need to write is this line here. This you should be able to do in your head, but if you're not sure, please write it down in your answer. Question 2. Gwen bought a new car. Each year the value of her car depreciated by 9%. Depreciated means reduces, gets lower. So I'm just going to put that on there as a little note. Calculate the number of years after which the value of her car was 47% of its value when new. So it's a bit of a strange question, and I'm going to present what is hopefully a logical solution to it. It's a little bit of writing, but hopefully it will make sense. We need our multiplier first of all. So we have 100% is the initial value of the car, and we are taking away 9% every year, so we are left with 91% of the value of the car after the first year. So our decimal multiplier is 0.91. Again, it's the same sort of thing we're going to do for all of these questions. Then I'm going to say, let's let x be the initial value of the car. Hopefully it will become clear why I'm doing this. Now we know that the initial value of the car, x, multiplied by 0.91 to the power of years, we don't know how many years it is, that's what we're trying to find, that's our unknown, has to be less than or equal to 47%. So in simple terms we're going to say, let's just work out a whole bunch of 0.91 to different powers, and when I get to less than 47, that's the number of years I have. So let's have a look. 0.91 after 2 years to the power of 2 is equal to 0.83. So that means my car is now worth 83% of its initial value. And that's no good. So let's go to 0.91 to the power of 3. So 3 years, after 3 years, that's 0.75. So I've got 75% of the initial value. I want to get to 47. This could take a little bit of time, so I'm going to just do a big jump. I go to 0.91. Let's just guess 10 years. What's the value of my car after 10 years? Oops, it's 0.39. It's 39% of the initial value. So that's too many years. So we're looking at somewhere between 3 and 10 years. So let's try 7 years. 0.91 to the power of 7. I put that into a calculator, I get 0.52. So after 7 years, my value of my car is now 52% of the initial value. Not quite enough. Pretty close though. So let's just try 8 years, 0.91 to the power 8. That gives me 0.47. That's 8 years. So the number of years of years is 8. It's a bit of a long-winded way, but in reality you're just tapping in a very similar calculation into your calculator multiple times. I would write the methods down, write the scores down, just double check they make sense, and then you're clear to go. Okay, in this question we have Bill invests £500 on the 1st of January 2004 at a compound interest rate of R% per annum. So we don't know what the interest rate is. The value V pounds, we don't know that either, of the investment after n years, number of years, we don't know that either, is given by the formula. Here we go. So here's the formula. V equals 500 multiplied by 1.045 to the power n. So V we know is the initial value, okay, of the investment. And we know that n is the number of years. First part here says write down the value of R. So R, where's R? R is the compound interest rate, the percentage rate. So the compound interest rate, let's think about it. That's going to be inside here somewhere. It's going to be this thing here. Now we know that 100% as a decimal is 1. So that's what this 1 is here. So what I've got here is actually my initial investment, 100%, plus a percentage, which is my R%, and then it gives me something that eventually as a decimal is 1.045. Well, 1.045 as a percentage will be 104.5%, so then my R must be 4.5%. Hopefully you can actually see, you can clearly read it straight away from just looking at this. It's the 0.045. The 45 then is 4.5%. It says, part B, use your calculator to find the value of Bill's investment after 20 years. So we have the formula, so V equals 500 multiplied by 1.045, so they give us all the formula. N is the number of years, so that's 20. You put that into your calculator and you get £1,205.86. And again, remember, go to 2 decimal places for the money. Final question. Viv wants to invest £2,000 for 2 years in the same bank. He has a choice of banks, the International Bank and the Friendly Bank. They both offer slightly different deals. The International Bank offers compound interest, 4% for the first year, 1% for each year afterwards. The Friendly Bank also does compound interest, 5% for the first year, and then 0.5% for each year after. At the end of 2 years, Viv wants to have as much money as possible. Which bank should she invest £2,000 in? Well, the way to do it is actually to work out what the investment will be worth on or in both banks. So, first of all, the International Bank, TIB. Now, year 1 will be £2,000 multiplied by, and it's adding 4%, so my multiplier is 1.04, which gives me a value of £2,080. That's year 1. Now year 2, the interest rate is different. So that's 2,080, the value at the end of the first year, multiplied by new multiplier, 1.01. That's £2,100 and 80 pence. The thing to notice here is this is not compound interest in terms of the previous questions where we have the same rate every year. This is compound interest when the interest rates change. So you have to do it every year separately. There's no power involved in this because we're just doing the 2 years. There's one rate for year 1, one rate for year 2. Let's look at the second bank, the Friendly Bank, TFB. And we have year 1. We start again with 2,000 and our interest rate is 1.05 or is 5%, which is a multiplier is 1.05. So at the end of the first year, you've got 2,100. That's the figure we start with in year 2, but the interest rate is now only 0.5%. So that's 1.005. Remember, 100% plus 0.5% is 100.5%, which equals 1.005 as a decimal. Bear that in mind when you're doing this question. So back to what we were doing. Year 2, 2,100 times 1.005, which equals £2,110.50. Now we are comparing this figure here with this figure here. And you can hopefully see that the friendly bank is the one that pays slightly more interest. So you need to write the statement as well to get the full marks. So TFB provides most interest. That statement is important, otherwise you're missing out on the final mark.